So for those of you who don't know me, this is my mini CV I've put up here. So I joined the department in 2002. I was 65% research, 35% teaching appointment. I'm a member of the Yale Nanjing Center on Atmospheric Environment. I've been an associate editor for Ag and Forest Meteorology since 2008. And I will be the chair of the American Meteorological Society Board on Atmospheric Biogeosciences starting this January. So very broadly, my interests are in the biophysical and biogeochemical processes that control energy and mass exchange at the Earth atmospheric surface or interface, and really the lower 1 to 2 kilometers is what I'm sort of very passionate about and interested in studying. For those of you who don't know me, I grew up near Niagara Falls, Ontario. I spent all of my education in Canada. Did my research up in Churchill, Manitoba as a PhD student. Spent 5 summers up there fighting polar bears and mosquitoes. Spent some time up in Inuvik, about as far north as you can go on the Canadian mainland, as part of the Global Energy Water Experiment. We were looking at evaporation rates from the Mackenzie Basin. Then I had the wonderful opportunity to work with Andy Black at the University of British Columbia, where he taught me a lot about micrometeorology and eddy covariance techniques, where we looked at the carbon budget of boreal forests in the very productive West Coast Douglas fir forests on the north end of Vancouver Island. Came here in 2002 to Minnesota, where a lot of my work was trying to gain greater process information by including stable isotope techniques with the atmospheric measurements that we were trying to do. So really sort of open up the black box on the exchange processes, trying to understand how ecosystems imprint signatures on the atmosphere. Where do I publish my work? The majority of my work has been published in journals like Agricultural and Forest Meteorology, Global Biogeochemical Cycles, JGR Biogeosciences, and Atmospheric Chemistry and Physics. Every once in a while we get lucky, we get a little bit better journal than that, but this is generally where most of my work has been published. I teach environmental science policy management 5402, which is biometeorology, and so this is really basically teaching the basic theory of micrometeorology and boundary layer meteorology. And what I've always tried to emphasize in my courses is getting hands-on teaching experience, or hands-on experience with the technique. So, Tomas, you're out there. I snuck this photo in yesterday's class. The class was looking at how to make a cycrometer for making water vapor measurements in the atmosphere, and eventually we'll use this technique to actually measure fluxes between the surface and the atmosphere. The other course I've been developing over time, and I've taught it in a number of different formats, ESPM 3000 as a seminar, as an honors course, and then last year as a grand challenge course, Climate Change Myths, Mysteries, and Uncertainties, where we're trying to teach the basics of climate change, and I use simple models like the parable of Daisy World to illustrate biophysical feedback in the climate system. So students are always very excited to run this model. We give them a MATLAB code, a compiled version of the model, and they're always fascinated to see that the surface temperature of planet Daisy World increases or decreases or stays relatively constant as you increase the power of the sun. And so we teach them a very important lesson about biophysical feedbacks taking place on planet Daisy World. Okay, I've tried to maintain a critical mass in continuity with respect to mentoring students. I've had a fairly good-sized group over the years. I'm getting more and more international students and scholars visiting on Chinese fellowships, which is very exciting. I got 1 minute, all right? I guess the thing that I find most challenging, of course, is trying to keep students funded. If you look at the current PhD graduation timeline, our students take about 5.1 years to complete, and a typical federal grant is 3 years long. So right away, you're in the hole, you're in debt 2 years. And so I'm hoping at the December 21st retreat, we spend some serious effort talking about this problem. My research mission here in Minnesota, back in 2006, I established collaboration with Minnesota Public Radio, where we are making very high precision trace gas measurements, greenhouse gases. And a lot of our work is right now focused on nitrous oxide. So if you look at fertilizer application rates and how that's going to change, there's going to be a huge amount of reactive nitrogen in the atmosphere. We're very interested in how that is going to impact atmospheric quality. We're looking at things like nitrous oxide and ammonia. So I'm being told to stop here. Just want to show one last slide. This is the nitrous oxide budget based on our measurements, and as you can see here, in 2012, huge emissions. This is one of the warmest years on record, the warmest spring in 122 years. So for those of you out there who are doing nutrient management type work, if you're thinking about mitigation efforts, warmer climates and wetter systems are going to really increase the emissions. You might have to be even more drastic in your measures. Thanks.
Great. Thank you.